scooch on closer to that intersection, press enter, and we get our estimate of about 3.7. Now keep in mind what we're keeping track of here. The input is still time, so we just found out that the ordered pair 3.7 comma 1.5 is where the two intersect. So what does that mean? Well, that means that after 3.7 years, or after about 3.7 years, do we want to round up to 4 years? Nah, we'll just leave the fraction of a year in there. The demand will reach 1.5 million. So will production. That's when they're both the same. So slow down production at this point, right? Because now they have no reason to produce more. They've actually maximized their production, and now they should probably do something like this, right? Start to produce more because they obviously are having trouble keeping up with demand, but then once demand drops, now they should be able to keep up with it. So they should be able to follow along and drop their production as necessary. Or depending on what their marketing strategy is, maybe they don't want to meet demand exactly. Okay, now mathematically what do we do? So D equals P, that's the equation that we wanted to solve. Alright, well, with equality, when two things are equal, I can always replace them with one another. So, for example, we know that D, the demand, is given by 1.9 minus 0.11 T. I know that production is given by 1.2 plus 0.08 T. So that means if they're the same, I should be able to replace them and put in 1.9 minus 0.11 T for D, and put in 1.2 plus 0.08 T for P. Well, what does that do for us? Well, now what I can actually do is solve for the time value, because that's the only variable I have. So if you wanted to do this algebraically, here's how you would do it. Now, do we really want to do it algebraically? Probably not. So we need to isolate the T's and we need to isolate the constants. Depends on how you want to do it. I'm just going to start by moving my constants over to the other side. That way, I've isolated at least one of the T's, and I get negative 0.7 plus 0.08 T. Okay, well now I've got to move over the T's and get them to one side. If I just subtract 0.08 T from both sides, that will allow me to get all my T's collected, and negative 0.11 minus 0.08 is 0.19 equals negative 0.7, and this zeroes out. So now I'm to the point where I can divide, because now I know that 0.19 times something equals negative 0.17. So that means negative 0.7 divided by 0.19 should tell me what that other factor is. So I do negative exit out of here, negative 0.7 divided by 0.19, and hopefully, boom, it gives me the same number, 3.7, which is what we got by actually solving graphically. So I now know that time is 3.7 years. Well, that still didn't really answer my question, because I also wanted to know how many units that would correspond to. Well, now I should be able to do either 1.9 minus 0.11 times 3.7 and figure out that my production, or my demand will be 1.1493, which is about 1.5. Now, what should my production be? What if I plugged it into the other equation? If I plugged in 3.7 into the other equation, then I should hopefully get the same thing, because that's when they're equal to each other. And, of course, you see a little bit of rounding error. That's because we rounded our time value, but they're both at about 1.5. So production is also 1.5. And here is the algebraic way of thinking about it.